Hi, hi, hi. How's everybody doing?
It seemed as if many bulging, watery, unwinking eyes looked oddly at me as I claimed my valise in the lobby, and I hoped that none of these unpleasant creatures would be my fellow passengers on
Pretty
the
well.
coach. For who could crouch blindly while a legion of croaking, baying entities of unknown source flopped noisomely past, scarcely more than 100 yards away? I thought I was prepared for the worst. Influenced by the shocking writings of... Their forms vaguely suggested the anthropoid, while their heads were heads of...
I absolutely love all the lo-fi mix channels that have been popping up on YouTube lately.
Their necks were palpitating gills, and their long paws were webbed.
And you all get that inflicted on you as well.
On 2 legs, and sometimes on 4. I was somehow glad that they had no more than 4 limbs. Their croaking, baying voices clearly used
Is
for
it still
orders,
September?
held
Why are we
no
doing
sign
Halloween
of the
already?
expression which their staring faces lacked. A monolith with indifferent geometry and a long, sharp shadow cast by the low morning sun. It is an ominous construction, channeling ancient powers and long-dead gods. Perhaps it is even connected to our primordial extraterrestrial ancestry. And now, just a few days before Christmas, this looming
Works
presence
since mid-August.
shows up
Oof.
mysteriously in the night, casting scornful shadows across both our
Yeah.
dreams and our primitive understanding of the world.
The way it goes sometimes, I suppose. No, not the Christmas stuff. Yeah, that's one thing I can't do Christmas until December. I start putting the Christmas music on in November, I can't handle it. Right. Thanks. Triggered. Oh, God. I probably deserved that. Alright, let's get the show on the road. Ah, cruel. You guys are so mean. I don't know why that gave me such a chuckle. Alright. Alright. Let's get moving along. So, how is everybody doing with the homework? Hopefully you are all aware. Go to our section here. That class sessions, software engineering, assignments, and GitLab. So it is due the 29th, right? So see it right there. Also, course information, calendar, 29th, GitLab part 2. So that is coming up. If you haven't started it, haven't looked at it, make sure that you, again, do the professorly thing and remind you to start the homework early. This is one that has technical requirements, and it's very easy to wait until the last minute, realize you have a problem, and then it's hard to fix the night that it's due. So please make sure you check it out. So if you have any questions, email me, Discord me, drop by office hours, whatever you have to do. I have had some questions trickling in, so that's good. I'm glad people are looking at it. I am subscribed to everybody's repo who has sent it in already too as well, so that's good. Um, One other thing I should note, so I added a reference to, so there's this Git book. I'll talk about, well, I'll talk about it now since I already have it up. This is helpful if you want to deep dive into Git. Honestly, if you do any Googling or searching or anything for a Git problem, chances are one of the results are going to link you to this book. It has pretty much everything you're going to need for a deep dive into Git, basically. So I'd highly recommend at least checking it out. You know, you don't have to pull down the PDF or the EPUB or whatever, but good to at least have it maybe bookmarked or handy or something like that. So that is up on the Blackboard page as well. And yeah. So today what we're going to talk about is we're going to wrap up our first bit of config management, and then we'll also hopefully wrap up the second bit, depending on how long I waffle on various topics. But we're going to look at both sides of the coin now. So last time we talked about basics of configuration management, right? So this is more, again, the subversion side of things. This is your traditional revision control, right? And what makes it configuration management? We're going to track things. We're going to manage our projects, okay? So here we have a little workflow. And again, we ended with development, CMs, release CMs, you know, all of the various aspects of what makes this fun from a software engineering perspective. So here's your workflow, and this is fairly standard across the board, okay? So let's say we have a software engineering project to do. That project will have milestones. And what is a milestone? That is a gate that you have to get through to move on to the next phase, right? Our unit tests are passed. We have made an integration release candidate inside of our system. We have finished our requirements gathering and we have verified and validated them and all that fun stuff, which we'll get to fairly soon. So milestone is something that we have to do, something that we have to make sure that we meet all the requirements for that milestone. Now, how do we know if we've met those requirements? Well, our configuration management steps in here then. So you create a project and think about this from a business level, make your project, go through all the rigmarole of speccing everything out, getting customer buy-in, everything that we have to do. In the configuration management tool, we have to create a project as well. You know, give it a name, give it an ID, whatever you're going to refer to this project as internally, you'll create that project. Important part, and this is what makes it interesting from, again, a SE perspective. You're going to create a bunch of tasks. These tasks will get tied to everything that you do in this tool. This is how you measure progress in your project. So one way you can do it anyway. So I have a change that has to be made on a release, for instance, right? So release my project. I have to update a requirement. I have to make a bug fix, you know, whatever it is. I have to make a change in the source code or a change in the requirements or a change somewhere. I'm going to tie this task to this objective. All right, bug fix. Okay, I can tie that task. Then when that task is done, I can say that we're done with this task, close it out, project moves forward, or we move on to all of our other tasks. Now, if you're envisioning, hopefully, you know, I'm going to do the hand wavy thing. You have your configuration management tool. You have all your tasks, all your code development tasks, let's say your requirements gathering tasks, you know, talk to the client, get their buy-in tasks, you know, everything that we have to deal with. Once we check everything off, project is green, for instance, you know, it is in a usable state. Are we done? Is the project completed? Question to you all in the stream. Including the people making fun of me about my love of Christmas music. No, exactly. Easy answer. We are not done. We're pretty much never done, right? So we have maintenance, we have follow-ups, we have testing, we might have more tasks coming in, right? We're not necessarily done until we've gone through the handover to the client or to the customer, right? Once they're happy, and everything's done, then life can move on. But there's probably going to be always some kind of a maintenance task we have to deal with. And one thing to highlight too, this is the last slide in this presentation, is change management. So I've probably alluded to this last time. Change management and configuration management, you're going to hear these terms. They're not the same thing. Basically, change management is a subset of configuration management. Um, change management is another process that we have to go through. And this is a process that occurs when some kind of a change or an update is required to a project. This is that process of creating a task and assigning it and going through every step that we can to make sure that this task is correct for the project, basically. So let's say you create a baseline, you create a tag, you create a release candidate, whatever it's going to be, and we're happy with it. We've got version 1.0. Well, something comes up, somebody screwed up, or there's a problem or a new requirement from the customer. We have to make a change. All right, well, fine, we can handle that. Thing is, though, we have a process for handling this change. So you have a process for a process for a process for a process. However many levels down you want to get. Basically, this change has to be handled in a strategic manner, I suppose. So what kind of a change is it? Right? Is it an emergency where all hands are on deck? We have to fix this major problem, put out this major fire? Or is it something standard, like a simple bug fix or a new basic addition? The point is that depending on what kind of a change you have to make, it depends on what type of people you have to have involved. Right? Do you need an emergency committee to convene and figure out the best strategy for handling this change? Or do you just have somebody on your project who approves changes that are, already knowledgeable about the system and they're fine with rolling things in, right? Or if it's pre-approved, you don't even need people. You just kind of work on it and add it in. The key here, though, is that we're still striving for that notion of consistency, right? So anytime that we have a change that rolls in, we're going to handle it with a flow chart that maybe looks like this that you see on your screen right now, right? You are going to try and basically make sure that everything is following whatever process you have for change management. Is this the end all be all of processes? No, absolutely not. I'm sure every company has a variation of this. But the thing to consider is that you, as maybe the lowly intern, lowly, I mean, interns are just as important. They do more work than most senior engineers half the time. But, anybody involved with the project, they're probably going to have to deal with this in some way, shape, or form. And whether this is communicated to you or not, there is something like this in place behind the scenes. So config management, change management, very similar ideas. Change management is just a part of configuration management. Alrighty, so that is it for part one. Now on to part two. Does anybody have any questions or anything like that from this set? Hopefully we are all good with that. Because what we're going to get into now is pretty much everything that I'm asking you to do for your homework. And I'm doing this backwards intentionally. So your homework, let's do the 29th, is all about getting up and running with Git and GitHub. Obviously, I'm having you get started on your term projects and all of that. What we're going to go into now is more of the philosophical differences of Git to some of the other tools that are out there. So this is all about the new Git paradigm. All right, so here we saw the classic view. This was used industry, academia, hobby projects forever if you were using revision control. Now we move on to the more modern side of things. And the spoiler here is that life is a lot, not easier, but it's a little bit more um, conducive to team-based projects, I suppose. So modern configuration management, i.e. Git, is basically a distributed view of revision control and source code management. We're going to assume that all of the config management tools are baked into this somehow. Right, a more modern take would be incorporating agile methodologies in here. So using things like a Kanban board or Scrum boards or things of that nature, and having that as a part of a Git system. Right, I kind of showed you before. I'm pretty sure I showed you before anyway. You pop over to your GitHub repos. You can actually set up, go to my term project repo, which unfortunately hasn't really had much action other than prepping for class lately. You can go to projects and you have all kinds of tasks, planning, tracking your progress. So these are all kind of part and parcel of your configuration management activities that you would see in other standard projects, I suppose. Alrighty, so enough high level blathering. Let's talk about Git. Excuse me. So, Git is by far now probably the most widely used source control tool that's out there. This number is a year or so out of date, so I'm sure it's even higher now. Git has an interesting history. And I say it's interesting because when I was teaching system administration classes, which is basically Linux, it's always fun for people to find out that, hey, the guy that wrote the Linux kernel also created Git. And why did he do this? Well, didn't necessarily have a good time with standard revision control with distributed teams worldwide, working on this operating system kernel. They wanted something better. So they wrote Git, and now everybody uses Git, which is quite interesting. Things to know about Git. So Git is open source, meaning that it's effectively free. You can run a Git server on your own. It's actually pretty easy to set up. There is a ton of DigitalOcean guides out there for whatever flavor of Linux operating system you run. You can run it on Windows, whatever your preference is. Nothing is stopping you from running your own source control, say at home, if you want a backup or something like that. Now, we've been talking about GitHub as your remote repository, right? That's where your term projects live. Hi, thank you. How's it going? Gotta say hi, it's 1 o'clock. Um, all GitHub is really a shiny web interface for a Git repository. All right. So for the longest time, GitHub did not necessarily provide free hosting for you. I think you had a handful of projects you could have for yourself. You couldn't really do anything organization based, which basically scales up the amount of things you can do with GitHub. Um, it was a lot less feature rich. It was more, I don't want to say niche, but it was more less feature rich, I suppose. So the other interesting thing too is that GitHub was not doing too well financially recently. So they were actually bought out by Microsoft. So I kind of find it ironic, humorous that Microsoft owns a open source, um, basically what amounts to a shiny front end for an open source project repository. The cool thing though is that if you check out Microsoft's GitHub page, they have a ton of stuff that they have open source. So if you're interested in any like type of Windows tools or Windows development, they have a lot of things out there. I think they recently open sourced PowerShell actually. So key takeaway here is that GitHub is just your interface for you all for a remote. Now you can run Git in the terminal. You can run you can run Git server in the terminal. You can run it, something like GitHub. There's also GitLab if you're interested in running your own version of GitHub. It's a Ruby application. I will say that it does take up a ton of resources. So if you want to run a server, make sure that it can handle GitLab's requirements. A lot of Minecraft Java Edition's code. Really, that's interesting. Minecraft Java Edition was open source. That's cool. So is it like most of the code and then all the assets are hidden or something like that? The standard thing. Speaking of Minecraft, just to do a brief aside, have any of you seen the Microsoft AI tool for Minecraft? I've been wanting to play with that, but I haven't gotten into it. It's like Project Malmo or Malmo? Microsoft Minecraft AI. Project Malmo. Yep. So basically, you do AI research using Minecraft, which I thought was kind of cool. brief aside, nothing wrong with that. Alrighty, so you can run Git yourself is kind of the whole takeaway from this this slide. Right, and one of the other cool things about Git, which is I think a testament to how flexible it is that everybody can have a slightly different workflow for how they handle Git, and I mean that internally to a team member. So here is a, again, sorry for the slightly pixelated slide, I just wanted to make sure it was blown up appropriately. This is this particular person's workflow circa 2008. It's a little bit different from the one that I showed you in your lab manuals. Even if you read his blog here, he links to another person's workflow, which is different than his. And the interesting thing is that no matter what your specific workflow is, you're going to end up in pretty much the same state in your team's repository. So if you have a workflow which works for you, the developer or the software engineer, whatever your role is, more than likely you'll be able to use Git without, too many headaches. And I say that this is a super positive thing because the more standard approaches are very, very rigid. They're very regimented with how you handle check-ins and releases and all this kind of stuff. Git is a lot more flexible, which is nice. So to explain this figure a bit, we have kind of your standard-ish Git workflow. So here we have some databases where these are just basically file stores. So you have your workspace, which is your project folder in your computer. You have an index, you have your local repo, and then you have your remote repo. So the index we haven't talked about, right? This is basically what your staging area is. I've got some extra stuff on the screen there. So when you do like a git add, the staged files go into your index. Your local repo is basically your local Git server database. I will talk about this in a moment. And then the remote, this would be the equivalent of your GitHub or your GitLab or whatever it's going to be. So some different flags here. We have git add -u. -u is basically only handling the files that have been modified for you. So you've been doing git add dot or git add asterisk if you've been following the lab manual. I know I can't handle my headphones today. Um, Basically, the flag that's here, so this -u doesn't handle untracked files. So if you add something new to your repository, this will not catch it. Git add dot will. And for me, that's how I like to run my Git. This person wants to add it manually, basically, which is fine. Then we have git commit. So we have the -m and the commit message. Basically, they do it a slightly different way. And then push to the remote, which you all have done as well. All right, here we are doing a pull or a rebase. Basically, we're getting our repository to the updated or current state, pulling to get the changes or rebasing to get, maybe a different branch or something like that. We can do some checkouts to pull a different commit. We can run diff, which is a way of checking differences in files and folders. I forgot to add the link as well, but there's a tool that I wanted to show off called diff merge. So this is one that I like. It is a free tool. Not sure if it's open source or not, but I'll throw it in the chat here. I love this tool. I've been using it since I was even before when I was an intern in industry, and probably now that I think about it, 2004. When we were doing GitLab Part 1, were we in the workspace or the local repository? That's a good question. Because Part 1 was the Flash, or no, Flash is dead. That was the webified tool, right? So that was learn. I think you were on your yeah, you were in your local because you were doing commits and pushes and things like that. Right, so yeah, you were on your local. Yeah, okay. Yeah, so the only thing with that one is it's more to get you used to the terminology. It's missing some steps and some flags, so you didn't get everything, which is kind of why we're doing the lab part 2 and we're talking about this stuff today. So, where's that? Oh yeah, diff merge. So this is a handy tool, and you might have a tool that you prefer, which is fine. I like this one because it's easy to use. I'm not sure if there's a Mac version or a Linux version. I've been using this on Windows forever. But this gives you kind of a nice way to compare two folders and the contents. So on the left, I have my GitHub repo, and on the right, I have the old version where I was starting to do things by hand. So I just click OK, and it gives me a list of all the files on the left and right. So obviously not a lot of things match up because they're completely different projects, but I added a README here, and we see there's a difference because it's red. What's the difference? Well, here it is right next to each other. I added just a dummy addition here basically. But I can very easily merge my changes back and forth. In this kind of a tool, again, don't have to like this one. It's free, which I like. But this is the kind of thing you will have to do when you start getting into merging and merge conflicts and things of that nature. So in your remote repository, whether it's Subversion or Git, if there are changes up there and you have changes in your local version, you have to figure out how to merge your code together. This is one way that you can do that. Git will actually have a command line diff tool for you. And depending on your graphical tool, there might be something nice baked into that as well. But here's one way you can visually see what the differences are. I can do this in the terminal as well if I want. So I can do diff readme, go to this other folder, and then we get a very similar view. It's just more terminal based, so it's not as pretty, obviously. So the right file has this difference at line 2. Get used to doing diffs because it's something you'll probably end up having to do. But this is one person's workflow again. I like mine because it's fairly straightforward. This one has a bit extra if you're going to go through that. Alrighty, so moving on. Let's talk about what the repositories are and why these are special. So the repos we have seen so far that they have commit objects, right? I've been talking about commit objects and doing commits. Well, what are these commits? They're basically changes to your repository, and a change has whatever the objects are that are impacted. So what is the current state of your project? It's going to have an ID associated with it, that long hex string. It's basically a SHA-encoded hex string, effectively. So we're going to have a set of these objects. The commit objects have what was changed. And then we're going to have a reference to something called a head, which we'll talk about soon. Basically, that's what the current version of your project is at. And the interesting thing about Git repos, too, is that they're stored in the exact same directory as your project. So if I pop over to my terminal here, and I do ls, just to show what's in here, I don't see a .git folder, right? It's not there. The way my terminal has things is that the highlighted guys here are folders, and these are just files. If I do ls-a to show all the hidden files, oh, hey, there's .git. If you're looking at this in the file explorer, you have to show hidden files and folders, basically. But if we look inside the .git folder, here are lots of things which might sound familiar to you. Right? We have a head, we have branches, we have objects, we have references, we have our index. That's, again, our staging area. One thing I will say is if you feel like you screwed up your repository and you want to kind of cheat and edit your local repository, try not to change anything in here because it's basically a database. If you mess it up, you'll basically blow away your local Git repo pretty easily. So I'd avoid touching anything in here. But the thing of the matter here is that if I delete this folder, this is no longer a Git repository. It's just like any other folder. So this .git folder is telling Git that there's something here. So this is your local repository, right? And I'm saying local intentionally. Why am I saying that? Because Git is a distributed system. So you have your local repositories, which are on all of your computers, right? You each have a copy of your term project, your team's repository on your machine, or you will by the 29th anyway. The remote repository is what you are all pulling from. All right, so that's going to be our GitHub for this project. So it's distributed. And here we have a figure that's going to compare the two. And I really like this figure because it really shows the differences. So this is Subversion, which is our standard source control model. You have your central repo somewhere, right? So this is a server up in the cloud, or maybe it's on a desktop somewhere in your office, wherever it is. There is a server running SVN software or Perforce or whatever you're using, right? All of the config management-y type activities are going to be up on that server. So doing branching, merging, reverting, blame. This is fun when you can blame other people for their problems. Everything happens up here. What you're going to do in this stat or this model is that you're going to pull down, basically it's called a sandbox or a working repository or a working directory or whatever it's going to be called for your environment. But it is a local copy of all the folders and files that you have to work with. All right, so what are the things that you're going to be pulling down? They're going to be in this local sandbox. If I want to make any changes, I have to go through the process we talked about last time. I have to figure out what I want to work on. I have to lock them, make my updates, and then push them back up to the server, right? And if I lock anything up here, nobody else can change it, right? So that's kind of the downside. This is a kind of a single point of failure type of model in a way. Now this is fine, and this was fine for the longest period of time, but we discovered a better way in Git. So all of these server-side activities get pushed down to your computer. And this is the distributed nature of things. So on this remote, this is basically, again, it's a server somewhere, but all of these activities you would do on the server, you can do down here. So there's no notion of locking, really, right? You don't necessarily have to do that. You have your own local repository you can work on and get it into whatever state you want. Now, the cynic in you might say, well, what if somebody pushes their changes up first, right? That's clearly going to be one of the bottlenecks here. I mean, that's not necessarily a problem. That just means that you have to merge your changes into whatever has been pushed, right? So that's when you get into those diffs, right? I'm going to merge my code into what has been changed. Alternatively, that's why I tell you to do a git pull before you start working on something so that you make sure you have the latest and greatest before you start making your changes and going through all of that. Anything else here that I want to talk about? Yeah, basically that's pretty much it. The Git model has really enabled developers to have, I think, at least a better time. Personal history, for the longest time in industry and even personally when I'd run my own little source code management servers for personal hobby projects, I'd use Subversion or variants of. I liked this model. It made sense logically, but once I started using Git, I honestly haven't looked back. I like it so much better. So that's my kind of personal side of things. It took some getting used to. There is some banging your head against the wall to get used to it, but at the end, it's actually pretty helpful. So moving on. So we have this distributed notion. We have kind of still your standard paradigms are going to, would you have to branch and merge? Would you need to branch and merge with a new pull if you know somebody updated the remote repo? So if you know an update has occurred, you have basically two options. You could branch and work on your thing in parallel and then merge later, or you could merge now and add your changes to those changes basically. Um, one thing which so there's numerous ways you can go about handling that quest. So that's a really good question, honestly. There's numerous ways you could handle this, honestly, and it's whatever your workflow is going to be. If it were me and I knew changes had happened, what I would probably do is I would clone another repository. I would run a merge, a diff program. So I'd like pull up that diff merge thing and see what the changes are. And I'd copy mine over into the new repo and push that up or bring theirs in. Basically, yes, you're going to have a way to handle that kind of a conflict. But it's going to be up to your own personal workflow, honestly. What works best for you. Make sense? I hope anyway. All right. So let's talk about some of the commit objects then. So we already talked about commit objects earlier. The kind of interesting thing though is that you have what's called a SHA-1 identifier. So again, this is just a hex string of seemingly randomly generated numbers and letters. Hex being A through F, if you're familiar with base 16. But if you have two commits which are exactly the same files, same changes, same messages and parents and connections and all that, the ID is actually going to be the same. So just something to watch out for, honestly. Interesting thing about Git, this is going to look very similar to what we saw with branching in the subversion model. So we have commit, commit. So these would be your check-ins, checkouts kind of thing. So I've checked in a version, checked in a version. Oh, we branched, checked in another version, keep going. So here we have a branch, effectively. Now, same ideas apply. We can merge it down. We could just end the branch and keep going with our main line here. Just depends on what you're looking for in your repository. Maybe this is a dead feature or something that nature. Branching is still the same here. It's actually a little bit easier, honestly, in Git. Okay, question for you all. Those of you who are familiar with Git may know the answer already, but how do we figure out which objects are which in Git, especially if we don't know or understand their identifier? Because again, the thing with Git is that their IDs are seemingly randomly generated, and they're not randomly generated, they're intentionally generated. But in the standard model, they're incremented, right? It's 1.0.1, 1.0.2. So if I know particular version number, I can go back to it. Here, it's a big blob of hex data. Anybody know how we could find a commit message? Any guesses? Otherwise, my gif of Louise is going to stand here twitching her eye at you. Does it have anything to do with the git commit-m? Could you echo the identifier? Those are good guesses. So yeah, we can actually pull down git commits by their, basically we can look for their description, we can guess at their ID, we can echo the identifier, sure. Easiest way is with the git log. So let's clear this out. Git log. And again, this is where it was kind of a leading question where if you weren't aware there is a log, here it is. If you go to GitHub, you can actually see this information in a very pretty interface. I'll show you that momentarily. So git log will show the entire commit history of your repository. This is whatever the current state of the repo is when you last pulled it down. So here we have our commit ID. Our head is pointing at the master node. So basically we're at the very end of our main line. So this is the newest thing. But we see author, we see the date, and we see the commit message. This is why I kind of mentioned that having a good commit message is helpful for looking through your commit history. So adding experimental things, this is probably a terrible commit message because what does that even mean, right? But I can grab a commit based on its ID. I can grab a commit based on part of its ID. So let's try grabbing FF85 here. Git checkout FF85. So the interesting thing here is I didn't put the whole ID in there, right? So if I do git status now, my head is detached. Actually, it gives me a bit more of that hex string. So what Git does is it tries to find what the commit identifier is based on what you are telling it. All right, so I gave it a little bit, and this was enough to uniquely identify the commit. And if there is a conflict, it will tell you that basically you need more information or it can't find it. I can also just check out the master. So a couple of messages here I should probably talk about. Head is detached. meaning that that head pointer is now pointing earlier in the tree. All right, so I'm not at the latest and greatest. I can do git checkout master to get the latest thing. So now my head has moved. And just think of basically a pointer moving around commit IDs. So if any of you have had like data structures, we talked about something like a linked list or a map or anything like that, you're going to have nodes pointing at each other. This is basically just moving a pointer from the head or the master to another commit and then moving it back. And that's just pulling the state of the repo down at that point in time. Kind of a very nifty way of handling it, honestly. It's very lightweight. It's very computer easy to do, I suppose. Like it's not a lot of effort for the computer to move a pointer around. All right, so that's make sure I didn't want to talk about anything else there. Yeah, that's basically one of the ways we can do that. And I wanted to show off, show this in GitHub, sorry. So if we go back to my term project here, I can see the commit log. Let me zoom in a little bit. Right here. So it's not obvious it's a link, but the link to the Git manual was in the previous slide, right? It's in the Blackboard right here under the course information. So in GitHub, you see this little 14 commits link. So yours will be different based on how often you've committed. I should mention too I think the theme of Git is commit early and commit often, I think is their byline. Because commits are pretty cheap to make, honestly. Cheap computation and storage wise. So if you click on the number of the commit link in your main GitHub repo, you see all the commits that have been made over time for your project. You can see what branch it's on, which we'll talk about branching in a bit. All this is a prettified version of that Git log. So here's the comment, here's who made it. You can copy the ID. You can browse the repo at this point in time. So if I want to see what the old version of my repo looked like, again, this is just a nice web front end. It's just the Git log in the state of the repo at that point in time. Now, I want to show you something interesting that I didn't realize. This popped up in the last class. I pulled down a Godot procedural generation tutorial for fun. I just wanted to give it a shot. Haven't really looked at it yet, but it's a GitHub project. So I see they have a .git folder. And again, this is just one that I randomly cloned to try to play with it. Interestingly, and this is kind of something I wanted to point out, is that your email address that you signed up for with GitHub is publicly available in here. So just be aware that when you commit something, it's pretty easy to pull down your email address. So I would use maybe your school one or one that you're comfortable being public. Not necessarily something to worry about, just things like this always tickle the privacy concerns in the back of my head. So just something to be aware of. Nothing wrong with this, and honestly, not everybody's going to be looking in here, obviously, for emails, but just something to keep in mind. I signed up with my Oakland email and now my GVSU email, so if anybody wants to find that, that's okay, but just be aware of it, I suppose. Alrighty, so you can look at the log in the terminal and in the website. You can do the same thing in GitLab if you get that up and running on your own. All right, a few more things to talk about. So Git heads. I've been talking about this notion of a head. This is just a pointer at what the current commit object is that you are basically working on. So right now it's pointing at the master, which again is being renamed to main fairly soon in Git. But this is just pointing at the end of the main branch. So commit 1, commit 2, commit 4, commit 5. This is the end of the main line. Head is pointing at that. I can very easily move the head to point at, let me get my pointer since me doing this means nothing to any of you. I can have it point at commit object 2. That's basically what I did earlier when I checked out that ID. I just moved this head node to point here. Now you are going to always have a head. You're always going to have a main in any GitHub repo or any Git repo. So just be aware that's what a head's doing. It's a reference. I already talked about referring to a commit object, so we can skip that. Branching. This is something that we would do in Subversion. This is something that we do in Git. The reasons why are exactly the same. So if you're wondering what specific reason could I have to branch in Git, all the answers that you gave me last time for the standard model apply here, right? I want to work on a feature. I want to work on a product line. I want to do something experimental. Throw it in a branch. Same reasons apply here. Interestingly, in Git, branches and heads are pretty similar ideas. So if I'm going to move my head node around, I'm effectively creating a branch light kind of a thing. So if I move my head node to B here, and I start working on B, and I start checking things in, I'm basically creating a branch off of B. That's good. I'm glad I could help there. So just the thing to keep in mind, if you start moving your head node around, you're basically going to create a branch by default. Not necessarily a bad thing, but you might end up with a dangling commit, which may have features that you want that you have to merge in later. So just something to keep in mind. So here's actually a nice visual example. Let's say that I fix something in commit B. That's not necessarily reflected in your head here because I made the fix back here. I can move the head there. Actually, sorry, the fix is the branch. Commit D is going to be the actual fix. But I have now this branch. And the thing to keep in mind here is that you're going to have this thing called a master/main in your project. Usually it is a good idea to have this be the latest and greatest thing because that's what other developers are going to check out, right? They're going to come to your repo, assuming you're using GitHub or whatever you're presenting to the world, and they're going to just pick the master branch or the main branch now. Usually that's the one that you want to keep stable, but there's nothing stopping you from saying, hey, my fix is the best one. Maybe later when we get to our integration, we'll merge it back into the main or something like that. Just kind of a nice thing to do, honestly. So one thing that we can do too here is we can actually create this. So let's do that in my term project here. All right, so I'm going to clear this out, and I want to create a branch. So I am going to do a pull, make sure I get the latest from my repo. Already up to date. Perfect. You know what? I have this in my history here. So I'm just going to hit up a bunch of times to get to my checkout. So I'm going to check out this commit. Again, I'm in a detached head state. That head pointer has moved up, or moved down, depending on your point of view, I suppose. Basically, we're no longer at the end of the tree. So this information is actually kind of helpful to read if you've never read it before as well. Your detached head, you can look around, make changes, and commit, discard, blah, blah, blah. Basically, anything I do here is probably going to end up making a new branch. This is what it's telling you. All right, so let's create a branch. Git checkout -b test. This is effectively a shorthand for just creating a new branch called test. So the -b is saying, if there is no branch called test, make a branch called test. And this is allowing me to name it right now. All right, so let's update README. So this is my README for this project. The spoiler is that I'm probably moving away from Barelib Terminal and moving to Pygame because I'm really starting to get frustrated with it. So I did something in Pygame and it took a lot less time. This is my update. Class ends in 10 minutes. No, 5 minutes. Have a good evening. Creativity T is waning. Sad face. Alrighty. So I've made changes to my README, okay? Doesn't matter what the change is. I could update everything. Who cares? As long as an update has occurred. I'm going to do my git add dot. This is going to, again, add everything that has changed, including untracked files. If we followed the other workflow, the -u, it would still work fine, but anything new that I added would not be tracked. Okay, so we've done that. git commit -m. This is a new branch for an experimental README. Cool, cool, cool. Now I'm going to try to do a git push, and this is not going to work. 2 seconds before I do it, why is this not going to work? Anybody that maybe is a Git expert already and you're bored out of your skull because you already know all this. But there's something key here that hasn't happened. Five, four, three, two, one, hitting enter. Missing the key. I did pull. So the issue with this, and this is something that you wouldn't necessarily know if you've never created a branch before, but Git has no idea about this branch in the remote. So I actually have to say to my remote repository, create this branch. So I don't have to merge because there's no changes on the remote yet. So basically it's telling you, here's the command you need to have this branch be recognized on your remote. So git rgit git, let me push set upstream origin test. So create a branch off of your origin called test. I'm going to log in, and I'm going to log in, and it's going to go up. So we see a new branch called test. It is now a remote branch as well with the git push. Where is it at? So this is going to push the changes that were committed from my local to the remote. It's also going to set an upstream branch called test. Let's let me clear this out to get rid of the cruft. Git status. I'm on branch test. I am up to date with origin test, nothing to commit. So everything's good locally. Let's pop over to my remote. Exit. Maximize and check things out. Refresh. Hey, I have this weird little message here. Test had recent pushes 1 minute ago. That's weird, right? Well, I am on the main branch still. You know what? I'm in a weird URL here. Let's get rid of this and go to the actual project. There we go. So still the message is here. Your branches are listed in this little dropdown. So there's master and there's test. I see 2 branches here as well. So there's all the changes that have been occurring between branches. We can talk about pull requests later on. Basically, this is saying I want to make a change. That's kind of like your task type of thing. But if I pop over to test here, now GitHub will show me my test branch. And hey, here's the update that I made. It's only available in test. Now, if I do git checkout master, I switch to the master branch, and I look at README, I don't see those changes in there, right? Because I'm now on the main branch locally. I do git checkout test, I look at the README, there's my update. So I've made a branch on my own computer and on the remote with that push. So anything wrong with this? No, absolutely not. But now I have a development path going in 2 ways. So anybody have any questions on what we talked about today? Next time we'll wrap up with a little bit about merging, and then we'll get into some requirements engineering, I think. It should be lots of fun. Anyway, let's get some sweet outro music. Halloween mix. Anyway, I hope you all have a wonderful day. I'll see you Friday. And if you have any other questions, please feel free to let me know. Bye, everybody. Oh. Ugh. Killing me, Smalls. Again, I probably deserve that. Bye. Man.